Hello and welcome. I'm thrilled to be your guide on this AWS Solution Architect certification journey. Whether you are a seasoned professional or just starting out, I'm here to help you succeed. Let's embark on this learning adventure together. Welcome to 591 Lab, where excellence meets opportunity. 591 Lab, the definitive choice for IT enthusiasts, and our offices located across China, Hong Kong, Taiwan, and Singapore. We deliver unparalleled exam preparation for your success. We specialize in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet certification. We ensure your readiness for the dynamic IT landscape. Further elevating your capabilities in AWS, we boast a remarkable track record in AWS Cloud Practitioner, AWS Solution Architect Associate, AWS Security Advanced, and AWS Solution Architect Professional Certification. We have a proven excellence with a history of knowledge, excellence, and outstanding success rate. We are your go-to destination for achieving certification milestone. So let's embark on a journey and thus join 591 Lab today to embark on a transformative journey that not only advances your IT career but also propels you towards your loftiest goal. Your success story begins here at 591 Lab. We are dedicated to crafting success stories. Begin your journey with us and unlock a world of opportunities in the IT realm and especially in AWS Cloud. So, our today's agenda are listed as follows. So basically we are focusing on AWS SAA-C03 certification, that is AWS Solution Architect Associate certification. So I'll be just trying to convey which path to move forward. So for that we'll be discussing a bit about AWS certification path. I'll also try to let you know the different fee structure for different courses that you are trying to certify. And our primary goal today is to discuss the AWS exam question related to AWS Solution Architect Associate. That's why I've highlighted out over there as well. So besides the exam preparation questions, so I'll also try to give you some very good useful links that you should refer in order to excel in the examination. For that, you need to follow ramp-up guides, AWS Builder Labs, and hands-on tutorials, which are quite awesome. So with regard to AWS certification path, so if you can clearly see that AWS has categorized it into 4 different quadrants. One is a foundational course, that is Cloud Practitioner. The other one is an associate level course, which consists of a bunch of courses ranging from AWS Solution Architect Associate, System Administrator, that's also known as SysOps, then the Developer Associate, and the Data Engineer Associate, which is in beta version. So it is going to be launched in full phase very soon. So in the professional domain, you have a course named Solution Architect Professional, and the other one is a DevOps Engineer Professional. So that is a path that you follow after doing your AWS Developer Associate course. So apart from that, you have the specialty course, and there are a bunch of courses that you can go through in order to specialize in a particular area. So if you want to advance your knowledge in the AWS Cloud in the area of networking, then you can go for advanced networking. Similarly, if you want to be a pro in database, then you can follow the database specialty path. Similarly, there is a course on SAP on AWS as a specialty course. You can have a specialty course in machine learning. So there is also a specialty course in AWS security. And there is a course in data analytics, but this course is going to be deprecated by AWS by April 2024. So let's move forward. So generally there is a kind of questions hovering around your mind. So what roles will I be getting after going through various courses? So AWS has clearly given the roadmap for different roles and responsibilities. So if you want to be a solution architect, then you need to follow the courses as listed here. So here the foundational course, that is Cloud Practitioner. After completing this, you can go for Solution Architect Associate, and after doing that course, it's better to move for Solution Architect Professional. And if you want to have a deep dive into and get and deliver the maximum out from yourself, then it's better to have a security course. So this 4 pool of courses, if you can do, then it will pave a path for you towards Solution Architect course. Now next is Application Architect. So in order to be an Application Architect, so the number of courses that you need to follow in track are Cloud Practitioner, Solution Architect Associate, Developer Associate, DevOps Engineer, and to really become a good application architect, the deep dive course on Solution Architect Professional is highly recommended. So AWS has put these 5 courses in this basket in order to be application architect. Similarly, there are different roles, and AWS has clearly classified the courses that you need to take in order to become or handle a particular role. So here is a cloud data engineer role, and they have listed these courses as Cloud Practitioner, Solution Architect Associate, Data Analytics, and Security Specialty. However, the Data Analytics is going to be deprecated in 2024 April, so maybe Data Engineering course will be incorporated into this basket. Let's move forward. So there is another role, that is Software Development Engineer role. So here, in order to be a software development engineer, you can take the Cloud Practitioner, which is a foundational course, then go with the Developer course, and then DevOps Engineering Professional course. So if you want to be a system administrator, then you need to follow this path. First Cloud Practitioner, then you go with a SysOps Administrator course, and then DevOps Engineering Professional course. So if you want to be a cloud engineer, if you want your title to be as a cloud engineer, then you are recommended to follow this path, starting from Cloud Practitioner, moving to SysOps Admin, then to Security, and then deep dive on courses like DevOps Engineering Professional and Advanced Networking. So in this way, AWS has clearly mentioned which course to take for which roles or job title. So you can just go through these and then prepare according to your choice of interest. So still there are other roles that have been listed out here along with the corresponding course that you need to follow in order to land a job in a particular area with a particular role or job responsibility. So there might be a question hovering in your mind, how much do I need to pay for the certification course? So here I have tried to list the fee for each and every course that you have to pay if you plan to go for the certification course. If you go for this Cloud Practitioner course, then you have to pay 100 USD. And so let's just give you some hint of how you can reduce the price. So there are some courses in AWS Skill Builder. So if you try to complete those courses, then you are provided with coupon giving you a 50% discount by AWS. So that is one area where you can cut down your bills. The second one is, let's say if you are going for associate or a professional certification, it's better to appear in Cloud Practitioner Foundational course. So it has around 100 USD. Then if you move to another course, then you will generally get 50% discount. So if you go for AWS Solution Architect Associate course, then you will be able to give this exam for around 75 USD. Whereas if you go for some specialty course like DevOps Engineering, since you have already done this one of the AWS course, that is AWS Cloud Practitioner, then the fee for this would be around 150 only. So this is one way how you can reduce the bill for achieving your AWS certification. So for some other courses that are there, so these are the price range that you can refer out here. Today our primary discussion is on AWS Solution Architect Associate exam questions. Let's proceed with the questions now. So this is the first question that I am going to discuss now. Let me go through the question. The infrastructure team at a company maintains 5 different VPCs. Let's call these VPCs A, B, C, D, E for resource isolation. Due to the changed organizational structure, the team wants to interconnect all VPCs together. To facilitate this, the team has set up VPC peering connection between VPC A and all other VPCs in a hub and spoke model with VPC A at the center. However, the team has still failed to establish connectivity between all VPCs. As a solution architect, which of the following would you recommend as the most resource efficient and scalable solution? So there are 4 options provided to you. The first one is use a VPC endpoint to interconnect the VPCs. Second one is use an internet gateway to interconnect the VPCs. Third one is establish VPC peering connection between all VPCs. And finally, use a transit gateway to interconnect the VPCs. In order to answer these questions, you need to have the knowledge of each and every item given out here in the options and try to focus on the key points given in the question. So here, what is desired is wanted to have a most resource efficient and scalable solution. So this is one of the key points given out here. Another one is this VPC A is in a hub and spoke model and is unable to establish connectivity between all VPCs. So we need a solution that's very efficient and scalable in nature. Thus, you need to have the knowledge about what VPC peering is, what VPC endpoint, internet gateway, and transit gateway all mean. With VPC peering, you can connect to number of VPCs, but you need to be aware that VPC peering is not transitive in nature. So VPC endpoint, basically you can connect with other VPCs by making use of AWS private link. Internet gateway is basically a way to get and reach the internet from the VPC. And AWS Transit Gateway is a service introduced by AWS which you can utilize between your VPC as well as on-premise. Thus, having a broad picture of each of the services, what we can say is that VPC peering is basically for private traffic and it facilitates private IPv4 and IPv6 traffic routing between two VPCs. And the limitation of VPC peering is the transit peering is not supported in case of the VPC peering. Thus, an alternative approach against VPC peering would be a transit gateway, which basically acts as a network transitor for broader VPC and on-premises network connectivity. If you go for the internet gateway, then it's basically designed for communication between VPC instances and the internet, lacking the capability to connect VPCs and on-premises network. On the other hand, the VPC endpoint is basically for private connectivity. It employs a VPC endpoint to establish private connections between your VPC and supported AWS service and VPC endpoint service via AWS private link. And one of the limitations of VPC endpoint is that while it's suitable for connecting VPCs to specific AWS services privately, a VPC endpoint does not support interconnecting VPCs and on-premises network. Finally, creating VPC peering connection between all VPC is deemed to be inelegant and cumbersome for establishing comprehensive connectivity. Thus, the recommended approach would be transit gateway. It's better to opt a transit gateway as a more efficient network transit hub to seamlessly interconnect multiple VPCs and on-premise network. Utilizing a transit gateway to seamlessly interconnect multiple VPCs definitely provides a scalable and redundant solution. So on the basis of the entire discussion, we can conclude that option D is the best. The second question is as follows. An e-commerce website is migrating towards a microservice-based approach for their website and plans to expose their website from the same load balancer, linked to different target groups with different URL: health.mycorp.com, www.mycorp.com, mycorp.com/product, and mycorp.com/orders. The website would like to use ECS on the backend to manage these microservices and possibly host the same container of the application multiple times on the same EC2 instance. Which feature can help you achieve this with minimal effort? You are given the 4 options out here. The first one, network load balancer plus dynamic port mapping. The second one, application load balancer plus dynamic port mapping. The third one, classic load balancer plus dynamic port mapping. The fourth one, application load balancer plus reverse proxy running on a Docker daemon on each ECS host. In order to solve this kind of question, what I would recommend is try to see the options provided. If you can remove them from your selection, if they do not really match with the questions that are being asked. So here, option C, the classic load balancer plus dynamic port mapping. So I say this option can immediately remove from our choice, as because classic load balancer is already deprecated. And if you go to option D, the application load balancer plus reverse proxy running as a Docker daemon on each ECS host, here leveraging ALV's native capabilities avoids the complexity associated with implementing and managing a separate reverse proxy running as a Docker daemon on each ECS host. Further, if you move back to option A, network load balancer plus dynamic port mapping, basically network load balancer is best suited for use cases involving low latency and high throughput workloads that involve scaling to millions of requests per second. Hence, application load balancer can automatically distribute incoming application traffic to various targets including Amazon EC2 instances, containers, IP addresses, and Lambda functions. ALV effectively manages varying application traffic loads within a single availability zone or across multiple availability zones. Dynamic port mapping with ALV enables concurrent operation of multiple tasks on the same ECS service within a cluster. ALV's direct dynamic port mapping feature, along with integration with ECS, eliminates the need for separate reverse proxy solution, simplifying management. Thus, leveraging ALV's native capabilities avoids the complexity associated with implementing and managing a separate reverse proxy running as a Docker daemon on each host. This option B provides an efficient solution for handling dynamic port mapping in the ECS environment, and hence the best option for this question so that can handle all those websites given out here could be option B, that is applicable. The third question is, a company hosts a popular web application that connects to an Amazon RDS MySQL DB instance running in a private VPC subnet that was created with default ACL settings. The web servers must be accessible only to customers on an SSL connection. The database should be accessible to web servers in a public subnet. Which solution meet these requirements without impacting other running applications? Choose 2. So you are provided with 5 options, option A to option E. Let me go through all of them. Create a network ACL on DB subnet, allow MySQL port 3306 inbound for web servers and deny all outbound traffic. If you see this option, then what you can realize is that our default network ACL already allows MySQL port 3306 inbound for web servers. From this, you can conclude that this is not a viable solution. The option B that is provided out there, create a DB server security group that allows MySQL port 3306 inbound and specify the source as a web server security group. So create a DB server security group allowing MySQL port 3306 inbound and specify the source as web server security group seems to be a viable solution in order for the web servers to be accessible only to customers on an SSL connection and the database to be accessible to web servers in a public subnet. So option C, if you see here, option C, the default network ACL already allows HTTPS ports 443 inbound for web servers, and hence this seems to be a false solution provided out here. Moving forward to option D, the MySQL DB instance listen on port 3306, not HTTPS port 443. Hence, we can also eliminate this option, that is option D. The final option provided, so here, create a web server security group allowing HTTPS port 443 inbound traffic from anywhere and apply it to the web servers seems to be a viable solution in order to provide access to the customers on an SSL connection and the database to be accessible to web servers in a public subnet. Among these 5 options, what we can conclude is that option B and option E provides good fit for the questions that are being asked, where we need to access the web servers only to customers on an SSL connection and the database to be accessible to web servers in a public subnet. Hence, option B and option E. The 4th question is, several Amazon EC2 Spot instances are being used to process messages from an Amazon SQS queue and store results in an Amazon Dynamic DB table. Shortly after picking up a message from the queue, AWS terminated the Spot instance. The Spot instance had not finished processing the message. What will happen to the message? For this, there are 4 options given. The message will become available for processing again after the visibility timeout expires. The result may be duplicated in DynamoDB as the message will likely be processed multiple times. The message will remain in the queue and be immediately picked up by another instance. The message will be lost as it would have been deleted from the queue when processed. So in order to answer this question, you need to have a thorough knowledge on the Amazon SQS queue. With regard to option A, the visibility timeout is the amount of time a message is invisible in a queue after a reader picks up the message. If a job is processed within the visibility timeout, the message will be deleted. If a job is not processed within the visibility timeout, the message will become visible again, could be delivered twice. The maximum visibility time for an Amazon SQS message is 12 hours. The message will become available for processing again after the visibility timeout expires. Now if you move to option B, we can analyze this option as follows. The result may be duplicated in DynamoDB as the message would likely be processed multiple times seems to be logical. As the instance had not finished processing the message, it should only be fully processed once depending on your application processes. However, it is possible some data was written to DynamoDB. If you move to option C3, that is option C, the message will remain in the queue and be immediately picked up by another instance. Seems to be illogical. As mentioned above, it will be available for processing in the queue again after the timeout expires. Moving forward to option D, the message will be lost as it would have been deleted from the queue when processed. Also seems to be incorrect. The message will not be lost and will not be immediately picked up by another instance. So looking at these points for different options, what we can deduce is that in Amazon SQL's visibility timeout is the duration a message remains invisible in the queue after being picked up. If a job is processed within this time, the message is deleted, otherwise it becomes visible again, potentially leading to duplicate deliverables. The maximum visibility timeout is 12 hours. Therefore, the statement the message will become available for processing again after the visibility timeout expires is accurate. Option B, C and D are inaccurate explanations, as they wrongly suggest message loss, immediate processing or potential duplication in Dynamo. The fifth question is, a company runs its infrastructure on premises and wants to establish a disaster recovery solution on AWS. The company suffered several outages in the past that resulted in critical data loss. The company has a limited budget for the DR solution and needs to keep the absolute minimal solution of the core production components active on AWS at all times. The solution must provide the ability to quickly provision a full production environment in case of an on-premise major outage. The company needs to ensure the quickest recovery within the budget constraint. Which of the below disaster recovery approaches would be recommended to satisfy the requirement? 4 options given are as follows. Option A, multi-site. Option B, warm standby. Option C, backup and restore. Option D, pilot light. In these questions, the key words that are given so that we can crack the solution for this is that the company has a limited budget for this DR solution and needs to keep an absolute minimal version of the core production component active on AWS at all times. So these two are the key words that you need to focus on in order to answer this question. When you design and build an application, a typical goal is to have it working. The next is to keep it running no matter what disruption may occur. It is crucial to achieve resiliency, but you need to consider how to define it first and which metric to use to determine your application resiliency against. Resiliency can be defined in terms of the metric called RTO, Recovery Time Objective, and RPO, Recovery Point Objective. RTO is a measure of how quickly can your application recover after an outage, and RPO is measure of the maximum amount of data loss that your application can tolerate. So option A, that is multi-site, is also known as hot site approach. It has very low RTO, minutes or second, and it's very expensive. Full production scale is running on AWS and on-premise. Option B, it's a full system which is up and running but at minimum size. Upon disaster, we can scale to production load. Backup and restore, it has the high RPO and RTO, so the slowest DR approach and does not have active component in the DR side. The final pilot light, a small version of the app, is always running in the cloud, useful for the critical core pilot light, very similar to backup and restore, faster than backup and restore as critical systems are already up. Thus, evaluating all the features for these different options provided, pilot light has a limited will fulfill your need if you have a limited budget for the disaster recovery solution, and to keep the absolute minimal version of the core production component active on AWS at all times. Pilot light would be the best solution. For question number 6, a company data center has application that has to communicate with a database hosted in a private subnet in the company's AWS VPC. The traffic between the application and database is not latency sensitive and is light. The company's security policy mandates using end-to-end encryption for any communication between an application and a database. What is the fastest and most cost-effective way to achieve this? The 4 options given are as follows. Option A, establish a direct connection between the data center and AWS VPC and use TLS HTTPS for end-to-end encryption over the connection. Option B, set up a VPN connection to the VPC's virtual private gateway and use TLS HTTPS for end-to-end encryption over that connection. Option C, launch a Bastion host on an EC2 instance in a public subnet and use it to allow the application and database to communicate. Option D, launch a Bastion host on an EC2 instance in a private subnet and use it to allow the application and database to communicate. Let's analyze the 4 options given. Option A, direct connect is not fast to deploy. It could take months to establish. For light traffic requirement that is not latency sensitive, this will be an overkill. Moving to option B, VPN is fast to set up compared to the AWS Direct Connect. An application and DB can use TLS HTTPS for end-to-end encryption. This seems to be a logical solution. Let's see the option C and D. Bastion's hosts are not for application to DB communication. Instead, they are for administrative purposes. Further, if you try to relate the option D, Bastion hosts are not for application to DB communication. Instead, they are for administrative purposes. Moreover, Bastion hosts should be created in public subnets. Further, Bastion hosts are also known as jump server. So it's a name that's quite popular in Australia. With the discussion of these 4 options given to us, option B seems to be viable solution for this question, as VPN is fast to set up compared to AWS Direct Connect, and the application and DB can use TLS HTTPS. We have discussed a number of questions related to AWS Solution Architect certification exam. So in order to excel in this certification exam, I would highly recommend you to go through these references which have been presented out here. The first one, exam preparation official practice question set. The second is AWS ramp up guide. Third one is AWS Builder Labs. And finally, the hands-on tutorial. I'll try to show how these pages would look like. The first one is exam preparation official practice question set by AWS. You can access it for free by enrolling out here. I highly recommend you to go through these questions before you appear in your certification exam. The next one is AWS Ramp-Up Guides for Solution Architect, which consists of most salient learning resources from AWS classrooms, digital curricula, video library, and AWS lab environment. Here you see services like Identity Access Management, KMS service, Compute service, the popular S3, that is Simple Storage Service, Elastic Block Storage, the various databases, and the troubleshooting with AWS, Amazon DynamoDB, and Amazon RDS. So for all these services, you'll find some video training on these and even self-paced lab, which I highly recommend you to go through so that it will give you a solid understanding. The next one is the AWS Builder Labs. So this is basically a self-paced lab in a live sandbox environment. I highly recommend you to go through these in order to gain solid hands-on skill. Next one is hands-on tutorial presented by AWS, which consists of various services out here. So if you click on compute, you will get the corresponding lab related to compute. If you go for containers, similarly you will get various labs listed out here related to containers. So I highly recommend you to practice these labs in order to have a solid understanding of the AWS platform, which would really help you to pass your AWS Solution Architect Associate examination. And not only this, these labs will definitely help you for SysOps, Developer Associate, the Solution Architect Professional, DevOps Engineering Professional, Networking Security. So this is a rich pool of labs which I highly recommend you go through these so that you will have a solid understanding of AWS, which would ultimately help you in your job as well. With this, I would like to conclude our session today. So I hope you found the material very informative and helpful. So again, I would like to emphasize that practice is highly recommended. Unless and until you practice, you will not be able to remember things and you will not be able to excel in your job. If you have any questions or concern, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes.